Okay, so I do have a loud voice, but this is definitely better. Thanks for that. Okay, so yeah, welcome. First of all, who am I? Just one slide. I'm a freelance software developer, white hat hacker, and trainer, focusing on Java, EE, and web security primarily. Speaker at conferences, and also you can find me on Twitter, my Twitter handle as well. So that's it for the introduction. Why security DevOps? Basically, we have some kind of ratio problem or frequency problem. So security, especially in Agile projects, is always some kind of bottleneck, either in terms of resources or in terms of time frames. And the DevOps movement has shown to us, as the security guys, that we are faced with more and more frequent rollouts, that we cannot pen test and cannot assure certain security checks at that very high speed, at that very pace. So there must be something that we can do to introduce into these kinds of vehicles of the DevOps movement, the kind of automation that drives all the automated rollouts, that also checks for certain aspects of security. And this is basically what this talk is about. And I will focus on open source tools to achieve that. So this does definitely not remove the requirement of a manual pen test. It's just about freeing the pen tester's time to hunt after the high-hanging fruits instead of again and again repeatedly finding the same low and middle-hanging things that should have been caught earlier. So basically it's about early feedbacks to the devs. So when talking about security DevOps as a concept, there are different levels of that. And they can be classified in something like a security DevOps maturity model, if you want to give that a fancy name. And this can be seen as a implementation of the OpenSAM's security best practices of verification, security testing, and code reviews. Also, it allows us to define a roadmap for projects implementing security DevOps into their Agile release management and build chain systems. So, as I've introduced some kind of maturity model, there are some steps, some incremental levels that we can cover and when talking about how to achieve that. So I borrowed the idea of referring to the color belts from the martial arts domain to stage and to grade these different kinds of steps towards a more mature security DevOps model. So we're not covering the implicit white belt, neither are we covering the really master belts, just a few incremental steps that we can achieve in our projects. So we'll cover 4 levels for each of different axes. So we have 4 different axes I would like to introduce and focus on 2 during that talk about the security DevOps maturity model. One axis is the axis of dynamic depth that we can achieve using automated checks in our security build steps on our security measures we take to automate certain security aspects in the build chain. Another aspect or axis would be to classify the static depth. We employ security concepts into our build chain. The third one could be the level of intensity. So basically, how strong are our security checks being deployed and for what are we checking about? And the fourth axis is the axis of consolidation. Basically, it's about closing the feedback loop back to the developers. Well, yes, you can do some kind of charting for that. So basically, that's more for the management to convince them to do something on that. So we're not covering all these topics here. So it's basically that you can do to measure your own project in terms of what you achieved. And I will cover 2, the dynamic depth and the consolidation axis, 2 axes in this talk, focusing on these 2. So let's explore these 2 by showing how to implement the certain steps with open source security tools we are eventually using already in our projects, but not in an automated fashion where there's some glue code or some glue steps missing, and I will show the necessary steps to achieve that. So this does not mean that commercial tools are not good at this. They are definitely. So there are a lot of good vendors in the exhibition area as well. It's just to emphasize the O of OWASP to definitely show open source tools and how to achieve that kind of thing. So let's start with the axis of dynamic depth. Basically, it's about, in a continuous integration in a CI system, about where within an application's attack surface, are dynamic security tests applied in an automatic way during the build process? How deep do we scan into an application? And we'll cover 4 different levels within that kind of access. The dynamic depth level 1, so the yellow belt, borrowing that from the martial arts domain, would be just to scan the spider and scan the public attack surface. So it's basically it's a simple to achieve. To have a pre-auth check about certain security vulnerabilities, no requirement to authenticate the scanner with the target, and basically we throw a tool at it pointed to the URL of the integration test system where during our build pipeline the software gets deployed automatically, and let's see what this tool generates. What do we have in our toolbox for that? One, obviously, you know, is ZAP, very great, Z Attack Proxy, very great open source flagship product of the OWASP. And it features lots of good stuff, but the feature set that is really relevant for security DevOps integration is, aside from obviously the scanning capabilities, being able to operate in a headless mode, also being able to be run as a daemon, having a good REST API that we can automate certain steps from the outside, that basically that it is scriptable. So how can we achieve some kind of automation by using ZAP in a build pipeline? So if you're using Jenkins, for example, as most people do, as their build server, that's quite easy. You can also do this with other build architectures as well, but build servers as well. But Jenkins, this is quite easy because there's a very, very nice and fresh plugin being available since a few weeks. That's the Jenkins plugin named ZAP Proxy. So basically named like the proxy itself, but it's a native Jenkins plugin that you can install in your build server. And this Jenkins plugin can spider and scan the configured URL of where your software was deployed on the integration test system during the build chain executing phase. So basically you can point that in the configuration to the URL and see what it produces. You can configure certain scan policies, certain types of attacks as well, using the ZAP policy files, and basically it emits some kind of report, either being human readable HTML or just an XML for further processing, and it's best to execute that on a separate Jenkins separate build job that's run on a nightly basis, for example, just due to duration, because this eventually might take some minutes or 1 hour or longer. So if you configure that in Jenkins, basically you get the way to define where on what port the ZAP should be started during that Jenkins build, and after that you can configure in the build step within the Jenkins plugin what the URL basically is of where to attack the target from the outside. So this should be the running integration test system that you use during your builds and during your functional testing and acceptance testing, if you do have any kind of automated tests for that as well. So after all these tests are fine, then you can run against the system the security tests just by configuring that kind of URL and letting it spider and scan that. You can choose the output format of being HTML or XML as well, and where it is being at the end of the ZAP execution being written onto the disk in the folder of where the build basically sits. So it's linked, the output is linked to the build. There's another good open source tool we can use, which is Arachne. Recently it received very, very good updates, and it's also very good for heavy JavaScript-based applications because it has a very good headless browser cluster that it executes to scan the application. Well, it does not have that much support in terms of like having a Jenkins plugin like that, but it also has automation capabilities like a very good command line interface or a remote procedure call API that we can use. So we can either run it inline in a command line step in the build, or we can execute it afterwards by having a web UI that we can then trigger using the RPC API as well. So Arachne and Jenkins can also be used, but as I already said, there's no plugin available, at least not that I'm aware of currently, that this natively fits into a Jenkins build. But due to its very good command line interface support, we could simply use a command line step within the build job to execute the Arachne scanner against our target that has been started in an integration test system during the build. And also that generates HTML or XML reports that we can then link from Jenkins to the build for further inspection. Should also be run in the nightly, obviously, not on commit because it takes quite long. There's another tool called BDD Security. When you're in behavior-driven design, then eventually you know the style of given, when, then storage that you can use to define certain test assertions or certain checks, and taking the behavior-driven design approach and transferring that onto the security domain basically is what BDD Security as a BDD-based behavior-driven design-based framework for functional and technical security tests does. Internally, it uses, amongst others, it uses ZAP as its attacking or scanning engine, but it wraps it into a framework that you can more easily describe tests with, having a very good human-readable language for that. So you can describe technical tests like scans, or you can describe functional security tests like privilege escalation checks focusing on your application or like. Due to the fact that this framework is using JBehave as being the behavior-driven design vehicle for that, it tightly integrates into the world of test automation, meaning in a Jenkins job, you can very, very good use the output of that kind of framework and process that further, link it to the build, like the JUnit reports you eventually know that can be linked in a build as well. You can drill down these things then. And also it tightly integrates with Selenium on the UI testing side, so to have a very good means of defining application workflows. Basically, this is what such a story looks like. It's given a fresh scanner with all policies disabled, and the attack strength is set to high, and the cross-site scripting policy is enabled, so you can define certain policies to scan only certain aspects if you like. When the scanner is run and false positives, that's an interesting point, are described here in a table, are removed. So basically it also has some kind of automatic false positive removal if it has been flagged as a false positive during the previous triage. Then it won't show up in further scans. Then no medium or higher risk vulnerability should be present. So basically the syntax is quite human readable and understandable. And what the framework does, it transfers that onto the correct configuration of the ZAP as a scanning engine, and later on it flags what has been found or not. Another one in that area is Gauntlet. Eventually you've heard that from different talks as well. Also behavior-driven design framework for executing many security tools. So it integrates with more scanners. Arachne, it can also integrate, or ZAP, SQL Map, more specialized scanner you already know, I think. And you can easily integrate your own custom tool, whatever you like to use, with Gauntlet. So that's especially useful if you want to execute a wide array of different scanners or different specialized tools against the target during the CI job. Then this would definitely a good idea to use. And in terms of integrating that into the build system, that's similar like with the BDD, but not that well integrated. So you can get a HTML report out of that scan that can then be linked in Jenkins. And also you can, with a little tweak on the source code, you can make it emit JUnit output format of the test cases, and then you can process them as regular unit test results in your CI system. Basically, this is all about the yellow belt scanning the public attack surface, having a tool, giving it a URL during the build job, during the nightly, and let's see what it produces. So what about the next, the orange belt? So level 2. That's basically about scanning in the authenticated parts of the application via the user interface layer. So it's about scanning post-auth and more deeper into the application's attack surface than only the public parts of it. So for this to be usable, we need to maintain, with the tool setup we use during the build automation, we need to properly maintain session state. Also, we need to have a way of logout detection so that during the spidering or scanning, if the tool, whatsoever reason for, gets logged out, it automatically, at first detects that, and then it automatically relogs in and continues where it has left off. So we can do this with ZAP, for example, in many ways. I represent a few of these ways. One would be to initially define a context in ZAP. That's a very, very powerful feature. So if you haven't looked into the context capabilities of ZAP, I definitely recommend that to you. Within contexts, you can define certain aspects for a scan that you use in ZAP. So the idea would be, in order to automate all this stuff, to use one time initially, manually, the ZAP UI, open it up, and browse a little bit in the application so that it gets to the login, and then you can define in the context of ZAP, in the context configuration of the default context, your authentication method. So whether it's a form-based one or whatsoever you use. And also you define credentials for the test users that should be used during that scan. And you define regular expressions for the logged in or logged out indicators. So basically it seeks then for a regular expression like, well, welcome so-and-so, or my account, or just the presence of a logout button is a quite clear indication of that you are logged in. Something like that, that you can distinct between these two states. And then the idea would be to save that initially session file in ZAP and put that into your source code repository, whatever it is. So that you attribute your source code repository that the build server like Jenkins uses with a individually configured to that application session file, where the authentication information is configured one time initially into that file. And then later on let Jenkins, the plugin we just saw, that executes the scan with ZAP on an automated basis on every nightly build or whatsoever, let this plugin pick that kind of session file and use it as a start for the scan. So then the automated scan has all the authentication steps it needs to do, properly configured for your application at hand. And it scans into the authenticated parts as well. So this is what I would recommend and do most of the time. So also you can use scripts if there's scripts in JavaScript or Zest, scripting language being supported by ZAP. This can be used if you need to have a more individual, more customized login that is not being handled by the standard ZAP login means. Then this, if it's complex one, multi-step one whatsoever, you can script that as well and provide that in ZAP. Okay, so how does that look like? In the context in ZAP, basically, which should be done one time, and you export that, save that as a session file into the source code repository, so that it gets picked up by the scanner. You define basically the target of the URL on the mode, form-based, the target of the form submit, you define the username, password parameters, etc., and regular expression patterns of how to detect whether we are logged in or not, which is mostly the presence of a logout button or logout link. And then in the plugin configuration of your Jenkins job, you simply use the load session field of that plugin configuration to start the ZAP scan and spidering during your build, and just point that towards the session file you just previously saved and checked into your source code repository. So this only needs to be changed if there's something to be changed in the way you authenticate your users with the application. Otherwise, this is a one-shot, and on every further scan, it will automatically pick up the right thing. That's quite easy. So then we can achieve the orange belt level 2, scanning into the authenticated parts of the application on every execution of that Jenkins build job or whatever build server you use. Okay, so how can we guide Arachne as another open source scanner into post-auth to scan in the automated security DevOps chain, if you name it that way. Basically, we can also give Arachne the information it needs to automatically log in and detect when it has been logged out. So there are two ways to do this in Arachne. One is to use its auto-login plugin that can be used. So basically, you specify the same aspects and the same things you specified in the ZAP dialog, which is basically the login URL. The URL here it is that carries the login page. The names that should be seeked in the DOM to get the form field names for the username, password field whatsoever. Obviously, the credentials for the user to test under. And a logged in indicator that is the presence of a regular expression match and the response of a website, web page that the user actually is logged in. And also some kind of excludes would be useful, that it's not spidering the logout link, obviously. And if it's more complex than just these configuration steps, you can alternatively write a Ruby script as well to do more complex logins that will be executed when the Arachne scanner detects that a certain pattern that you configure has a match that you're no longer logged in. So the easy way would just to in the command line step of Arachne scanner to attribute that you use the URL of where the login action is residing on, the login form, provide the username password values as a ampersand delimited string, a logout check, basically it's a regular expression to watch out for the presence of a logout button is clear indication that you're logged in. And you would definitively exclude the logout target that you're not spidering the logout by itself. Or an individual Ruby script if it's more complex. Okay, so for staying with the orange belt, when you're using BDD security, well, also we can guide BDD security into post-auth due to its very good and tight integration with Selenium for the UI testing and UI test automation. So you can use a Selenium class that performs the login. Obviously, if you do have some kind of UI tests, you most of the times have some UI tests that also perform a login as a start of the test. So you can reuse that kind of code of Selenium and integrate that with BDD security in a way I will show you on the next slide. And this is by creating a class. And you can then use this Selenium class in the BDD stories that you define to be run when this BDD security framework is executed during your build. So basically, you're extending a BDD security class, web application, and implementing an interface named iLogin that forces you to override three methods: the open login page method, the login method, and the isLoggedIn method that simply returns a Boolean, being the logged in indicator checked whether you're logged in or not. So this can be done by simply the open login method, open login page method, to simply navigate with Selenium during that kind of test case to the login page. And the login method itself simply submits credentials that are coming from a table that's referenced from a BDD file, so that you are having a separation of the test user accounts. And isLoggedIn simply does a regular expression match on that as well. So it looks basically like easy code, just some Selenium code that you use and to perform the login and to guide BDD security into dynamic scans inside the authenticated area of the application. It's using ZAP under the hood then. Okay, green belt, level 3 of the dynamic depth access. So this basically is a separate scanning of different layers of the application. So here the idea is not to only scan the public or the authenticated web UI, but also when you're having a service-oriented application or a microservice-based backend, then your web application obviously triggers some kind of, most of the times, some kind of backend calls, being it SOAP calls or being it REST calls or whatsoever. And the idea of the green belt, level 3 in the dynamic depth access would be to scan all these internal backend web services, being it SOAP or REST whatsoever, directly as well. Not only indirectly when you're scanning from the UI, because obviously some parameters make its way onto the backend, but also scanning it directly. So from within in terms of architecture or layers of your application. For this, we need to detect parameters within or injection points within XML or JSON data structures. And we need to place the tool we would like to do that during the automation scan in the build chain. We need to place that tool between the web application and the backend so that it directly sees this traffic. How to achieve this kind of thing with ZAP, for example? We could easily place ZAP because it's a proxy server, place that between the backend calls. So place it between your web application and between the target as a proxy. So you can attribute any kind of HTTP call to a REST or a SOAP backend to use a proxy, and this should be the proxy then that you use here with the ZAP. So ZAP can inject payloads into observed XML tags or attributes. Also, it can do the same with JSON, so it's aware of the language or the syntax structure for that kind of request. So then all you need is something that drives traffic so that you can capture in the proxy, you can capture certain kinds of requests that you would then scan actively. So this can be done either by directly or indirectly, either by executing service tests that access directly the service endpoint. Then you have, when you execute these and have the proxy running between the application and in front of, in this time in front of the backend call, then you can use the direct service tests, or you can use indirect tests generated by the UI so that you observe backend traffic and scan these directly. Anyways, then you need to set ZAP into its attack mode, which is basically automatically actively scanning new requests it sees during the passive or during the proxy listening. Also, there's an alpha level, up to now, alpha level SOAP scanner add-on available in ZAP. So if this shifts into beta level, this should be a candidate as well. How can we achieve that with Arachne, for example? Backend scans with Arachne can also be done in a way similar to the way that ZAP does that. Basically, we can train Arachne of the XML or JSON requests prior to the active scan phase by having it acting as a passive proxy between the server-to-server calls, between the backend calls. So there's a passive proxy plugin being available in Arachne that we can use for this. And then same with the ZAP slide before, we need to drive traffic onto the system by reusing existing UI tests or by using existing service tests. And that these communication paths go through the proxy, and then we can use the collected input vector data from Arachne and feed that into its active scan as well. So the passive scan is to train the XML and JSON requests to Arachne, and then the active scan can pick that up and use and select certain aspects of the XML structures or JSON structures where to inject the potential attacks to check them. So Arachne also understands, since version 1.1, XML and JSON input vectors automatically. Okay, so the blue belt, level 4, the axis of dynamic depth. This would be a targeted scanning. Targeted scanning of individual workflows. Wizards, basically. So not just spidering. So here it really gets individual. We need to follow distinct usage patterns of the application. As I said, as opposed to simple spidering. We eventually need to supply business logic compliant inputs to further advance in wizard steps like shopping carts, checkout processes, and so on, to scan the last step of that, for example. So they need to be executed in proper order with proper values. And there are many ways to achieve this with ZAP, for example, as well, in an automated build chain. 3 ways I will present. One way of doing this, the easy way of achieving that, would be the simplest, just to integrate existing Selenium-driven tests with ZAP by proxying the UI tests through ZAP in attack mode. So what this then does, for every new request it sees, by simply being proxied from the UI, existing UI tests you have that do execute the steps in the proper order, it just attacks in the background. Okay, that's easy. A more individual, a more customized version of it is to use a existing Selenium UI test and enhance that by calling ZAP's REST API at proper steps to start the attack there, at proper steps within the workflow that the Selenium UI test executes. So basically it's like unit test code that uses Selenium, and you attribute that by calling ZAP REST API that has been started as a daemon during the build in Jenkins. So just to have at certain steps a active scan for a particular URL be executed. This could be done basically by having a simple unit test like that, simple JUnit test with a setup method to initialize stuff and several test methods to test several steps of a wizard, like in a shop, like a checkout process, for example. The setup would obviously be to start a new proxy session with ZAP. So it should be started, the ZAP proxy should be started during the build in the background. There are Jenkins plugins for this as well available, so that you can then use the REST API, and ZAP has a very nice language binding for different languages, Java, for example, or other languages, that's very convenient to use. So basically, it's just start the new proxy session in the setup method and initialize the Selenium driver that you use during your UI tests to proxy through ZAP. The next step for testing a certain test method, a certain step in the workflow, would be to, for example, to use Selenium to guide the browser towards the spot you would like to test. For a shopping cart, this could be our checkout application in a shop. This could be a step to guide it to the shipping address step of a purchase wizard. And these Selenium steps could have been recorded, obviously, that you can copy and paste them from your existing recording UI tests. And then you need to finally configure the ZAP's attack strength and attack styles via a REST API in case you want only certain attacks to be executed, and need to call the ZAP API to actively scan the last seen URL from ZAP's history. So this can be queried via the API as well, and then you can say, please execute an active scan for those attacks on that URL within that session. And obviously, the same is true for other steps as well. Just repeat and continue that kind of pattern. There's a nice example available online on that kind of web page. The link is on the last slide as well. So that does steps similar to that, so that you can use as a very, very good starting point of how to integrate Selenium with the ZAP. Third option would be to use in ZAP in your automated UI, automated security chain, to use the sequence scanning plugin, which basically is a way of recording steps in an application with the ZAP scripts, but to train ZAP to guide you to the steps. But that's still alpha level, so eventually we need to wait until it shifts into beta level as well, but it's a very promising, interesting approach. Same can be done with BDD security. So with BDD security, we can use Selenium as well to, because it's very tightly integrated with Selenium, to define custom workflows. And for this, we need to implement Java interfaces of BDD security. I've already seen that, and navigate within the application workflow so that the BDD security scanning framework is then aware of the purchase steps or whatever you would like to test in a proper order. But what if no Selenium test code exists? If we don't have or don't want, due to whatever reason, Selenium tests, then this would be an idea to simply that at least developers use the ZAP UI initially to proxy the browser through the ZAP UI to to train it at least of those steps that eventually wouldn't have been found with the proper parameters by spidering, so that you can precede the steps and the requests in a ZAP session manually, save that session file as we did with the authentication information, export that or check that into your source code repository, and let that get picked up by the Jenkins plugin executing ZAP on every build. So that way you can at least train ZAP in a better way with proper parameters and proper request values of the steps that would have not been found that way by just spidering. Okay, so this was the axis of dynamic depth, a very big topic within that talk. As I said, there are 4 axes in this kind of security DevOps maturity model. The axis of static depth I will not cover in this talk. It's basically about using tools like OWASP dependency check or retire.js for the dependencies, using code scanning techniques with find security bugs, very good open source tool, or scan.js for JavaScript or Brakeman for Ruby on Rails. Neither will I show in this talk the axis of intensity. So this is basically of increasing the levels of scans, like from passive scans that can be done just by proxying through the existing UI testing code on commit up until heavy active scanning or custom rules. A few more slides I would like to show you is about the 4th axis of this maturity model. It's the axis of consolidation. Basically, consolidation is about what are we doing with all the findings we get during the build. Level 1, the yellow belt, would be just to generate some human readable report from that, at least, and link that to the build. Why? Yeah, good question. Why? Just for inspection. Then who's going to read that? That's another one. So you have to be process aware of that. Otherwise, you need to have another step, which is the orange belt. So you have to define more glue code. So few slides. So at least you could have some kind of report that is generated there, but then you need obviously some kind of process enabled that someone is reading that. You can use the HTML publisher plugin from Jenkins for that. Just picks up the report of the Jenkins, the ZAP scan that has been executed, and just links that then towards the build. Hopefully someone will read that. At least you can have, yeah, obviously. So you could have some face guides in place to inspect these. But sooner or later you will discover that you need to achieve the next part, which is the orange one, to have a custom logic to make the build unstable or broken on certain findings. Otherwise, if no one reads the report, you don't have any benefit from that. So for achieving that level, you need to filter the type of vulnerability, the severity, and obviously also the confidence level, and to break the build or make it unstable if there's any match. So how can this be done in a CI job? Most scanners emit XML reports that you can parse instead of the human readable HTML report. Simply, often a simple XPath expression is definitely fine with that, that you can use just to count whether we have some high severity and high confidence level ranked vulnerabilities, and if we do have some, break the build. But be sure to only break the build with really high confidence level findings, otherwise this could backfire if you're flooding the developers with broken builds due to lots of false positives. So sometimes when it comes to automation and breaking builds, less is more. Level 3, the axis of consolidation, would be to consolidate and really consolidate and deduplicate the findings, which is using the results from different tools, merging them, and eventually pushing them towards the established bug trackers known to the developers, so that you can do data analysis on that, and that you can do trends over the consolidated data sets as well. For this, you could use ThreatFix, very, very good tool. It's a server that you can start that basically imports native scanner results and has a way of deduplicating and consolidating them and pushing them forwards to the developers in IDE or in the bug tracker system. Okay, so last level, level 4, the level of consolidation is basically level for the blue belt, just to find the white spots or the unchecked areas within your project where you've not yet had good coverage of your automated security tests. And this is basically to find spots that should get a better code review. And for this, you could use the OWASP Code Pulse project, which is basically doing some instrumentation on the server during your executing of the security checks, and it generates a coverage report nicely represented as a tree map. Just zoom in, where you can see what kind of packages in your code have not yet been tested by these security scans, so that you're not in a false sense of security. So basically, that's it. Thank you very much for the talk. Yeah, thank you very much for attending my talk. And here are the links, and if you have any questions, we have 5 minutes. Yeah, here's one.
So in the static code before, you mentioned doing manual code review. Would you suggest doing something similar in dynamic code before? Manual pen testing?
Yes, obviously, good question. The question was, in the static maturity model access, there is a code review that should be used. Is there something similar in the dynamic level, like manual pen testing? So yes, this is not a level 4 of the maturity model in terms of the belts, because there are still more master belts being available. And the whole thing is about automating steps. So the manual steps should not be a part of that, but definitely it does not lift the requirement for manual pen tests. It's only to free the pen testers' time to really hunt after the high-hanging fruits. So please, yes, do manual pen tests as good as you can, and just free the precious times of this bottleneck for high-hanging fruits. Other question?
Yeah. Do you do any
Any few? Fuzzing, yeah. Good point. Yes, the question was whether there's some kind of fuzzing part of that. Yes, I do have something in the backup slides. In the maturity model, there is also some API security tests that you can use, which is basically using JUnit, existing JUnit tests to test the API on a direct core level of the methods. And for these, you can do fuzzing to detect certain steps. So there is basically a slide in this as well. I have to. Yeah, that's it basically. So where you can do security unit tests as well, and you can do fuzzing using tools like Radamza, which is a nice fuzzer, or values from FuzzDB, statically sourced, also very good, that you can throw at your API level and see what it generates by inspecting the error logs or something like that. Okay, other questions? Yeah, question.
For dynamic level 3?
Yes.
Sometimes you have to close this API that require security to find requests and so on. Do you get some support from that or?
Yeah, good question. Signed requests. So basically, all the hardening measures, like starting with CSRF tokens, captures, and stuff like that, that need to be used and properly used in the scanners as well. So at least in terms of CSRF tokens and captures, there are solutions for this available. CSRF tokens are handled, for example, by most of these scanners. Signed requests, it depends on what kind of the request is signed, with what kind of signature. So if you have some kind of weird spots where the injection should be placed during a scan, because you've got some base64 encoded chunk of whatsoever, and it's signed or whatsoever, that's not just a regular URL or form parameter, then you could use in ZEP a custom input vector script that you need to code in ZEP. And this basically does the finding of the input vectors in that kind of request parameter structure for you, being then fed into the scanner engine.
You're showing for both development and then also for security, there's great value in the testers.
Yep.
Right now you're leveraging way tests to drive a lot of the security tests through all the different dynamic websites.
Yep.
How do you go about motivating this QA organization to write those tests?
Yeah, that's very good. So as you've seen, good question. The question was, how can we convince the team basically to write the tests that we as the security guys can utilize as the driver, as the vehicle? And the point was, the more advanced levels we have covered in that maturity model, they rely on these kinds of tests. And from my experience, most projects have, if they are having some further mature stage arrived at that in terms of test automation, in terms of quality, they do have UI tests whatsoever, being it Selenium or other ones that you could utilize. But also, it would be a good idea to motivate the team, to do more of that. But it's easier than expected because most of these tests can be recorded. So if it's not done by the development part of the team, then at least it can be done initially by a security portion of the team or for multiple projects, so that you can, on a basis of prioritization, write some of these or record some of these scripts that then you can use. Question, yeah?
One question, I propose
Okay.
to take it offline.
Yeah, we have another talk.
We need some time to switch rooms.
Yeah.
Thank you very much.
I'm here for longer. Thank you.